Welcome back. Last time we talked about matrix operations, adding and subtracting. We can't divide. How to multiply by a scalar, just distribute in. Multiplying matrices, which is complicated, you multiply row by column, the determinant of a matrix, and the inverse of a matrix. Today we're going to use the inverses to solve matrices, but only for complicated ones. For simple ones like this, if I want to solve for matrix A, I need to get rid of this matrix right here. Well, it's being added, so I'll do what I would do for a regular algebra problem. I will subtract the matrix to the other side. Well, that's easy enough. But be very careful that you watch your sign. -6 minus -9 is +3. -11 minus a -8 is a -3. And -2 minus a -9 is a +7. Also, note the dimensions. They are all the same dimensions. To add or subtract, they have to be the same dimensions. Those are easy, so I'm not going to spend much time with those. They don't need an inverse. What about matrices that require an inverse? Like, let's say you have matrix A times matrix X equals matrix B. You want to solve for X. In algebra, we would divide by A. But remember, we don't have division in matrices. So I'm going to multiply by the inverse of A. Notice that the order that I wrote it is important. I have to do it on the left side. Remember, matrix multiplication is not commutative. So this is actually what we did last time. I taught you how to find the inverse of A on the calculator. I taught you how to multiply two different matrices. We'll use our calculator to do this. So I want to solve for X. That means that X equals the inverse of this matrix times this matrix. We can do that by hand if you'd like. I'm not going to. I'm going to use my calculator. The first matrix is a 2 by 2. 4, -2, -7, 2. Matrix B is a 2 by 1, and you know you're right because it looks the same as that. -6, 12. And I want to do operations. So I want matrix A inverse times matrix B. You don't have to put the multiplication symbol in there. It knows enough to do that. And it gives you the answer. It tells you that X equals -2, -1. So let's see how this can be used with a word problem or with a system of equations. This is a system. 2 variables, 2 equations. I can rewrite it as a matrix. Now let's see how I did this. The 2, the -3, the 1, and the 2 are the coefficients. The x and the y are the variables that you have. And the answer is the answer that you had earlier. So how do I use a matrix to solve this? Well, I want to get x, y by itself. I can't divide matrices, so I'm going to multiply by the inverse on the left side. And remember, order matters. Again, I'm going to use a calculator to help me, because I don't want to do this by hand. Second matrix, let's go to edit. It's already a 2 by 2, thankfully. So 2, -3, 1, and 2. Second matrix, edit B. It's also a 2 by 1, which is good. So -6 and 11. And I want to do matrix A inverse times matrix B. And I get 3, 4. So I get XY, matrix I didn't know, equals 3, 4. Now, we normally wouldn't leave it like that. Let's write it out. What's x equal? X equals 3. What's y equal? Y equals 4. And in class, we'll do a lot of examples with word problems that you have to read and turn into systems of equations, to turn them into matrices, to find the inverse. But this is the basic idea.